Today we will learn about the next chapter from our syllabus, that is viscosity and surface tension. Firstly, we will see about the viscosity. See, viscosity is a concern, this word is concerned with a property of a liquid. In previous classes, you may have been learned about the viscous nature of the liquids and the fluids. See, whenever a liquid flows slowly and steadily over the fixed horizontal surface, means that its flow is streamline and its a layer in contact with the fixed surface remains stationary, and the velocity of the other layers increases with the distance from fixed surface. Means as the layer we are going from fixed surface to inner side, the viscous nature goes on increasing. There is a regular velocity gradient set up in that liquid, and due to which what happens, the greater the distance layer from the fixed surface, the greater its velocity. We can say that velocity with the topmost layer thus moving fastest. Now, as in viscosity, there are different types of energies. Mainly, here we have to discuss the energy of liquid in motion. Whenever the liquid in motion, it possesses three types of energies, that is pressure energy, kinetic energy and potential energy. These are the three types. Here we will discuss it one by one. First of all, we will see what is a pressure energy. See, this is the energy possessed by a liquid by virtue of its pressure. Means that liquid having an energy which creates its pressure, and by creating the pressure, the generation of that energy takes place, and it is nothing but a pressure energy. For a clear idea, we will here consider this type of diagram. A liquid is here in this container, liquid of a density rho. This is a wide tank P having side tube. Here is the side tube near the bottom of the tank as shown in this figure. Then this is a frictionless piston. This is a piston. This frictionless less piston having a cross-sectional area A is fitted to the side tube. Then pressure exerted by the liquid on the piston is P equal to H rho G. See here what is the significance of these notations. H is nothing but the height. This is a height H. This is a height H of liquid column. Then rho is the density and G we know. Now if x is the distance through which the piston is pushed inward, see here, this is a x. Initially here is the piston and it takes this position. Therefore, this distance is x through which the piston is pushed inward. Then volume of liquid pushed into the tank is equal to A into x. See here, mass of the liquid pushed into the tank by the piston is nothing but Ax into rho. Therefore, as the tank is wide enough and a very small amount of liquid is pushed inside the tank, the height h and hence the pressure P may be considered as constant. See once again, when this happens, when a very small amount of liquid is pushed inside the tank, and due to which the height h and pressure P is not having much more variation, at that time it is considered as a constant. Now, if work done in pushing the piston through the distance x equal to, we have to calculate the work done. It is nothing but work done W equal to P into A into X. And this work done is the pressure energy of the liquid of mass AX rho. And see here, for calculating the pressure energy per unit mass of the liquid equal to PAX divided by AXP, and by which we are getting P by rho. It is pressure by density. This is the pressure energy per unit mass of the liquid. Then another concept of energy, that is nothing but the kinetic energy. As we know that kinetic energy equal to 1/2 mv square. See here what happens. It is the energy possessed by a liquid by virtue of its motion. By this we are getting, by this statement we are getting the idea of kinetic energy. What he says once again, we will see, it is the energy possessed by a liquid by virtue of its motion. Means that the energy possessed by a liquid by its motion is known as kinetic energy. See, for kinetic energy, F m is the mass of the liquid moving with the velocity v. The kinetic energy of the liquid equal to mv square. And then kinetic energy per unit mass is 1/2 mv square, and m equal to v square by 2. Lastly, here in concern with the potential energy, we will see what is the potential energy. In starting, we have started with pressure energy, then kinetic energy. Now we will see the potential energy. Potential energy is nothing but the energy possessed by a liquid by virtue of its height above the ground level. See the differences in the concept with these three energies. This is the energy possessed by a liquid of its height above the ground level. What about the relation here? He says that if m is the mass of the liquid, the height, that is h from the ground level, and the potential energy of the liquid is nothing but mgh. Therefore, the potential energy per unit mass, the potential energy per unit mass is nothing but mgh by m. Again, m will get cancelled and it is nothing but gh. See now what happens for the total energy of a liquid in a motion. At that time, we have to take in consideration these are three types of energy. That is a pressure energy, kinetic energy, and potential energy. By adding these three types of energies, which just we have worked out, then we will get the total energy of the liquid in motion. Means total energy of the liquid in motion equal to pressure energy plus kinetic energy plus potential energy. Therefore, total energy per unit mass of the flowing liquid, here P by rho, just we have been here, this is P by rho, it is a pressure energy, kinetic energy V square by 2, V square by 2 plus potential energy which is Gh. By putting these values, we will get the total energy per unit mass of the flowing liquid. This is nothing but the basic things about the viscosity. In next lecture, we will see about another things in concern with the viscosity. Thank you.